Welcome to the session. I am going to derive an expression for shortest distance between skew lines. In the last class, I explained what are skew lines. So, skew lines are the lines which are neither intersecting nor parallel and lying on two different planes are called skew lines. So let us start to have an expression for shortest distance. First let me tell you what is that expression and later on I will prove that. So see here there are two lines in space L1 and L2 and the line which is perpendicular to both these L1 and L2 is this PQ. This is the shortest distance between two skew lines. I explained it also earlier and we are interested in expression for this D. So suppose if L1 the vector equations of these two lines L1 and L2 are in this form, I will be explaining once again. So if these are the vector equations, then the distance between these two lines is given by this expression that we are going to prove in this session. Also, if the lines are given in Cartesian form like this, then the shortest distance between these two lines is given by this expression. So we will be proving the first one and that implies this one if you know the cross product of two vectors. Okay, so for them they think that proof is not important for me, and if they are little bit average in the studies, so better you just remember both the formulas in order to solve the problem. And if though are and for those who are interested in understanding theoretical concept, let's understand the proof. So anyhow, I will be proving it in detail. So in order to prove this, you need the concept of projection of one vector on the other or the projection of one line on the other. And one more thing, the cross product of two vector and its geometrical applications. Okay, so first let me tell you what is projection of line segment on another line. So here is a one line L and here is a line segment AB. The projection of this line segment on the line L is nothing but it is the distance between the two foot of perpendiculars drawn from A and B. So this MN, this length is called the projection of the line segment AB on the line. So this distance. So projection is basically it's the length of the line segment, means distance between foot of perpendiculars, which is always a positive. So projection of AB on the line L is MN. So let's understand one more thing of this. Suppose in terms of vector we talk. This is a line L and this is a vector AB. I want projection of a vector AB on the line L. So again you have to draw perpendiculars from these two ends on the line L. Okay. So if this is M and this is N, these are the foot of perpendiculars drawn from A and B. So MN is the projection of vector AB on the line L. As we know that vectors can be shifted without changing its direction and magnitude. So vector AB can be written in this fashion. Anywhere you can shift without changing its direction. So in all these cases, projection is MN only. Look at this. Here A is on the line L. So in this case also, it is m n. Okay. So suppose if this is an angle theta, so mn can be found in terms of cos theta. Okay, so that is we are going to use. So let us assume that, look at this figure and see the next one. So here is the vector AB and here is a line L and vector B along this line. Theta is the angle between vector AB and the line L. As I said, projection of AB on the line L means along the vector B is this distance, this length AC. So projection of vector AB on the line L is, it is length of this segment AC. Remember, projection is always a length. Okay. So now we want what is AC. So if you apply cos theta for this triangle, so cos theta is what? Adjacent by hypotenuse, that is AC by AB. Now we want AC, so cross multiply, so AC is equal to AB cos theta. So in this way you can find projection of one vector on the other in terms of angles, if you know the angle. So this concept again we are going to use if you want the detailed understanding of the expression for shortest distance. So remember this. Let's one more thing, the cross product of two vectors. Also I have explained it in vector algebra. So please once you have to see that before studying this three-dimensional geometry. So the cross product of two vectors A and B is denoted by vector A cross B. So it has two expressions, one in terms of sine theta and another in terms of determinant. Okay, so both you can see there. Here I will be telling only geometrical application of this. So the cross product A cross vector B is a vector which is perpendicular to both the vectors A and B. Okay, so suppose if A and B, this is a vector and this is vector B, this is vector A and angle between them is theta, then A cross B is a vector which is perpendicular to both vector A and B. Okay, so cross product is always a vector which is perpendicular to individual vector A and vector B. So remember this, we are going to use again this. So whenever A cross B comes, it is a vector which is perpendicular to both vector A and vector B. And n cap stands for a unit vector in this direction. Unit vector means a vector of magnitude 1 unit in the direction of vector A cross B. And this A cross B is such that it forms a right-handed coordinate system with these two vectors. Okay, so also this I have explained in vector algebra, what is a right-handed system, coordinate system. So let's proceed with this basic knowledge to prove an expression for shortest distance. So let's understand. Now see here, consider a coordinate axis. This is x-axis, y-axis, z-axis. Anywhere you take, you can rotate the coordinate axis. Okay. So these are two lines in space, line L1 and L2. And their vector equations are vector r is equal to the a1 vector plus lambda vector b1 and a2 vector plus mu vector b2. What these a1 and a2 and b1 vector and b2 vector stands for? Okay, I have considered a line L1 passing through a point S and line L2 passing through a point T. L1 is parallel to vector b1, as we know that what it stands for. Okay, this stands for, it is a line passing through a point whose position vector is a1 and parallel to vector b1. Similarly this. So L1 is passing through S. Let us call the position vector of this S as a1. So a1 is, vector a1 is position vector of S and vector A2 stands for position vector of T. Okay, and also we know that by the triangle of vector addition, this is ST is what? Okay, so or you can express any vector joining 2 points in terms of position vector, that is vector ST is vector OT minus vector OS. As I said, vector OT is vector A2 and vector OS is vector A1. Okay, so this also we require. And here PQ is our requirement. PQ is the shortest distance, means which is perpendicular to both L1 and L2, and we are interested in this length, that is D. That is the length of PQ. So this is your basic explanation. So whatever this I have explained in terms of words, so please note down this figure and write all these explanations by pausing the video. You just write down all this. Okay, everything explained there. So these are the two lines L1 and L2. As I said, this B1 is the direction of L1. Okay, looking at this, what it stands for actually, this stands for, it is a line passing through a point whose position vector is A1 and parallel to vector B1. So the direction of L1 is along the vector B1. Similarly, B2 is the vector along the line L2. Okay. Now we have drawn PQ perpendicular to both L1 and L2. So if we draw vector along this direction, okay, so if PQ is perpendicular to L1 and L2, then this vector is perpendicular to both L1 and L2, and this vector is your B1 cross B2. Okay, because B1 is the direction of this line and B2 is vector is direction of this line. So this is perpendicular to both B1 and B2, means it is B1 cross B2. So let us assume that the shortest distance is PQ is equal to D. Now, as it is a shortest distance, I said it must be perpendicular to both L1 and L2. Okay. So, if PQ is perpendicular to L1 L2 means the vector PQ, if we talk about vector PQ, it is perpendicular to both vector B1 and vector B2, because the directions of L1 and L2 are along B1 vector and B2 vector respectively. So that is the reason you have to write like this. Okay, let's see here. Let us call this n cap. Okay, so n cap, consider it is a unit vector in this direction. Unit vector in the direction of vector P, or a vector which is perpendicular to both L1 and L2. Okay, so let us call n cap is the unit vector in the direction of vector PQ. And as we know how you can find unit vector in the direction of any given vector. Okay, so unit vector in this direction means what? It is vector what? N cap is unit vector in this direction. So unit vector in this direction is, you have to divide that vector by its magnitude. So n cap is vector B1 cross B2 by its magnitude. Okay. Now also I told in the beginning how a vector can be expressed. Any vector means a quantity that has magnitude and direction. Direction means a unit vector along that vector. So vector PQ can be expressed as its magnitude and its direction. So what is the magnitude of PQ? Magnitude of PQ means length of the line segment PQ. Okay, so length of this PQ is D. Okay, so what is its direction? Its direction is this n cap. Okay, so vector PQ can be expressed as D into n cap. So understand this. Actually, we are interested in this length, and that will be got by projection method. So let's see further. I said earlier PQ is what? It is D, and which is nothing but projection of ST on PQ. How this has happened? As see here, as PQ is perpendicular to L1 and L2, so you can also that this line is perpendicular to PQ and TS is perpendicular to PQ. Vectors can be shifted, so you can understand that these are the foot of perpendiculars drawn from S and T. So definitely PQ is the projection of the vector ST. So to understand this, so here is the ST and here you have vector PQ. So the distance between them is D. So the perpendiculars, if we draw here by shifting the vectors, so we can find that this length is a projection of ST. So, and if you talk about in terms of angles, so if theta is the angle between PQ and ST, I explained how the projection is given by, it is PQ is equal to ST into cos theta. So PQ is equal to ST into cos theta, the angle between two vectors PQ and ST is given by this. Vector angle between two vectors is given by how? Vector A dot vector B divided by magnitude of vector A, magnitude of vector B. So here theta is the angle between PQ and ST. So you can write this. Now what is PQ? I have given there PQ is nothing but D into n cap, and vector ST can be expressed in terms of position vectors. This form also had given you in terms of position vectors. So substitute here, and vector PQ, magnitude of vector PQ means it is length of the line segment PQ that we have taken as a D, and magnitude of vector ST means it is length of the line segment ST. Okay, so now DD cancels and this ST cancels, you will left with this n cap into this. Now what is vector OT? It is position vector of the point T, so that is your A2 and this is your A1. Okay, so let's proceed. This is the thing. Okay, now D becomes, we also proved that what is n cap? N cap is a unit vector along the direction which is perpendicular to both B1 and B2. So that I have given you. So it is your n cap. So this is the required expression, or if you want, this is being a constant magnitude, you can write a total denominator. So this can also be written in this form. Okay, so understand this expression. Actually, if you know the scalar triple product, so this is a scalar triple product and which can be expressed in the form of determinant. Okay, so if you know the idea of scalar triple product, this can be useful in obtaining expression for shorter distance for Cartesian form. So let's understand the Cartesian form. See here, the shortest distance between the lines in Cartesian form. Suppose the lines are given in this form, Cartesian form, x minus x1 by a1, y minus y1 by b1, z minus z1 by c1, and x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. Then the shortest distance between these two lines is given by this expression. Okay, so understand this. This is actually your b1 cross b2 dot a2 minus a1. This is scalar triple product. It's okay. So remember this. If you want the proof of this, just comment. I can provide you the proof. So in the textbook, proof is not provided. So I think not so much important. It can be understood. So at right now you can remember this. Okay. So you remember this thing. So it very easily can understand. It's a b1 c2, as you can expand the determinant in the same way. Square root of b1 c2 minus b2 c1 whole square. Next a1 c2 minus a2 c1 whole square. Next b1 a1 b2 minus a2 b1 whole square. Okay, even if you interchange the terms, no problem, because you are squaring them. So definitely square of negative is going to be positive. So remember this. So we'll be doing some examples on this, and from the point of examination you may get one problem on this. Derivation is not going to be asked, I think, because there are so many other important derivations. So concentrate much more on the problems part.